Hi everyone, thanks for joining the talk. My name is Ashrya Agrawal. I'm a student at BITS Pilani. I'd be talking about bias audit, mitigation in Julia with Fairness.jl. AI is being used in numerous high-stake decision support systems like criminal justice, healthcare, financial services, recruitment, etc. Well, algorithmic decision making can overcome undesirable aspects of human decision making. Biases in training data and model inaccuracies often lead to decisions that treat individuals unfavorably based on characteristics like race, gender, disabilities, sexual or political orientation, etc. Multiple cases of unfair treatment have been reported in AI systems in numerous domains, in various general models, in loan approvals, advertisements, financial services, AI healthcare systems, AI recruitment systems, etc. So, who's the culprit here? Let's find out by inspecting a typical ML pipeline. Selection bias and historical bias are the leading sources of bias in data acquisition. Improper understanding and formulation of business objective also propagate bias. Feature representations can be biased due to the dataset. Model training propagates bias, while model inaccuracies are a source of bias. Improper evaluation or cross-validation can be a cause for increased variance in fairness. In production, the demographics and the distribution keeps changing over time and hence leads to outdated fairness parameters, which again causes bias. Improper modeling is also a source of bias. So you might be confused, why is there so much fuss about it? Can't you simply remove the protected attribute from the dataset? Well, it turns out that no, you can't do that. Let's see why. That's because protected attributes like race can also be inferred from other attributes. For example, zip codes are a proxy for race, as has been shown in the image. So you could say, let's remove zip code as well. Well, it turns out that protected attributes can be inferred indirectly from other features as well. For example, in a major healthcare algorithm, previous healthcare expenditure was serving as a proxy for race, leading to reduced spending on black population. Spending on pedicure, beauty products, etc. serves as an indicator for gender. Okay, so we agree that fairness in ML is a real problem. But how hard could it really be? Go there and apply some fairness algorithm and I should be done. Well, I wish it were that simple, but no. The first question we need to answer is, how would you define fairness for a problem? There are numerous fairness definitions, and a model fair with respect to one definition might be unfair with respect to the other definition. Fairness can result in a decrease in accuracy. So, how to be fair while minimizing the cost? Different countries have different bias groups, so a system must handle those differences. Surprisingly, the fairness algorithm could end up making the model more unfair. So we need to check that as well. Now, with this brief introduction to fairness and related aspects, let's dive in and learn more about Fairness.jl. So, Fairness.jl is a bias audit and mitigation toolkit which provides a collection of standard datasets, fairness algorithms, and a framework for extensive benchmarking of fairness algorithms. Bias can be mitigated at different steps in a pipeline. So, depending on this step, fairness algorithms can be categorized into pre-processing, if the input or training data is modified, in processing, if the training procedure is changed, post processing, if the predictions are altered or flipped directly. There is a one fits all definition for fairness. In criminal justice, you might want to use false positive rate. While in university admissions, you could use recall parity. This is why Fairness.jl provides numerous observatory fairness metrics along with their common aliases, which are visible in the slide. Fairness.jl provides these fairness algorithms and many more on progress under JSOC21 this summer. Now, let's see a typical Fairness.jl workflow. We import the required libraries, load the Compass dataset, which is a criminal justice dataset for predicting recidivism. And we import a neural network. Then we can wrap the base classifier and also specify the protected attribute. Now we can again wrap the model with another fairness algorithm by similar procedure of specifying the classifier that we have just wrapped above, and again providing the protected attribute. And with the linprog wrapper, we could also provide the metric that we want to debias against. And then use the MLJ pipeline, which automatically does the valuation and provides the result. So as you can see that the fairness did increase, while the accuracy decreased. But the decrease is lower. Finer control is also possible with Fairness.jl. We just need to partition, create a machine, fit, and predict, just the usual stuff. And then we can create a fairness tensor using those predictions and ground truth and get a fairness tensor, which is basically a stack of confusion matrices. Using this fairness tensor, we could get disparity values, and we have the freedom to specify the custom function for getting the disparity, and we can also calculate parity using the disparity values and get the data frame. This diagram shows how well Fairness.jl integrates with MLJ and the Julia ecosystem. We use Fairness.jl in an empirical study of debiasing methods for classifiers, showing that debiasers often fail in practice to generalize out of sample and can in fact make fairness worse rather than better. So, how Julia ecosystem helped us? Speed, flexibility, and composability were quite important. We also leveraged MLJ interfaces and structure, which enables us to study 150 plus ML models with the combination of various fairness algorithms and datasets. JUMP ecosystem helped in the easy formulation of optimization problems and fairness constraints. For our research, we need to create an extensive benchmark. So distributed computing made this very easy with distributed.jl. As for the future plans, 2 GSOC students are expanding the fairness ecosystem in Julia this summer. While Sumantrak will be extending Fairness.jl, Ashrya will be leveraging Omega.jl and Causal Inference.jl to develop toolkit for causal analysis of fairness. Thank you.